Hey guys, so today we're going to learn about sets and whole numbers, numerations, and computations. Module 2. Okay, so we're looking at a diagram. In the diagram, there's a whole of a universe, and within the universe there are sets of variables or numbers, or sets of numbers. So in our universe, we have the letters A, B, C, D, E, F, G, and H in the universe. And then we have separating all of those A, B, and C. All right, let's do an example. So we see that in universe A, we have B, C, D, G, and H. B is the only one in universe A, so we can write that in A. So let's mark B out. And then we have C. C is also the only other one in A. So let's mark that out. We notice that D is also in B and C. So it's actually intersected right here. And we'll talk about some of those mathematical terms intersecting in the universe in just one moment after we get through with this. So we are going to put D in the middle right here. That way we know D is in the middle of all of it. So let's mark off D. We also have G, which is also in C as well. So we are going to put G right here, explaining that it's for A and C. So let's mark off G. And we see that F is only in B. So we have F. And then H is also in B and C. So we have, oh, H is also in A as well. So we're going to put H right here next to D. And then we have A and E left. So where do those go? Well, they go on the outside of the universe. So here's A, and then here's E. So now that we labeled our diagram, let's talk about some of the mathematical terms we use. So right here, we have the intersection. We have the universe, meaning both. And then we have A, which means everything except A. That little line above it could be for any variable. It's everything except that variable. So let's look at some of our problems here. We have B and C, so both B and C. So what is all both in B and C? So we have F and B. Sorry, it's an F. And then we have D and H. D and H. And then that's it. Oh, we actually have G and C as well. Okay, so A intersecting B. So that's not everything in A and B. That's what intersects in between them. So let's look at that. So we have A and B right there. So it wouldn't be G and F. It would be D and H, because that's where they intersect in the middle. D and H. So we also have B intersect C. So here's B and C intersect C. So it's also D and H. So those are the only ones in the middle intersecting those two. So we have A union C, which is A and C. So let's go ahead and label what's in A. So we have B, we have C. Now let's look at we have G, D, H, and then that's what's in A and C. So right here on letter E, we have everything except A. So right here, it would be everything except that's in A, which would only be F, A, and E. So let's write that down. F, A, and then E. Those are the only ones not in A, included in A. So in letter F, we have A intersects C. So where A and C intersect, it's also G, D, and H. G, D, and H. I'm so sorry. I apologize for my mouse. It's so hard to write with it. But that's what I have. So right here. So if we notice that we've already labeled B intersects C, it's D and H. So we can go ahead and write those, because it doesn't matter what order they're in. As long as they're included overall, it doesn't matter what order we put them in. So now we just write everything that's in A. So now G, B, and C is all that's left in A. All right, looky there, we labeled the diagram. So we're going to look at another type of diagram, except for this one, we're going to be doing shapes. And in this one, I'm going to explain how the intersecting in universe brings in those shapes. So L would be large and H would be hexagons. So this would be everything that are large hexagons. All right, hex. That's large hexagons, both large hexagons. And then union would be like an and or kind of thing. So they can be circle, circular, or hexagon. Again, I really do apologize for this. I thought it would work out smoothly. So we did learn previously, if we look at letter C, we see that there's a line above the T, which is meaning everything except triangles. Triangles. So we're going to do not triangles. Not triangle. And then not triangular, but red. So red is included. And then we have down here in letter D, you have C intersect S intersect R. So C is again circle. So I'm just going to actually draw it this time. And small and red. Well, that's pretty simple. So in today's term, we use the decimal system, which is also known as base 10. Base 10, we use the base 10 system because when we count all the way to 9, 10 is where it starts over and it adds that 0, 1 to 9, and then 10 with the 0, and then so on and so forth. And then it would be 11, and then when 11 to 19 happens, we add that 0 to make 20. So we're actually going to look at some different base systems that we've learned. So this is actually the Egyptian base system, and they use these little images to represent numbers, and it's actually a very important historical fact with all of these systems because it's how we communicate with mathematics over time. It's how we've developed as a whole with mathematics. So right here we see that we have 3 of these 10,000 little items. So we already know that's 10 times 3 times 10,000, which is 30,000. And then we're going to put a plus there because we have 10 times 1, 2, 3, 4, 5 plus 50. And then we have 1, 2, 3, 4 of these little 1. So 4, and then that will give us 30,054. See, that was pretty simple. And then now we have the Roman numeral method. And then they use theirs by letters to represent numbers. So as we see here, we have 1,000. And then actually we have 1,000 minus 100, which is 900, plus another 1,000. And then we have 1, 2, 3 of these. So we have, let's just go ahead and add these. So we have 1,000, take 100 from that. So we have 900 plus another 1,000. And then plus, and we have 1, 2, 3 of these 10. So we have 30 plus 5 plus 2 plus 5, and then plus, see, that's where I get the 2 from right there, and right there. Just 2, and we'll go ahead and mark that off and put 7. So we should get 1,937 when we add a total. This one seems very easy, which it is, because It's actually the Fablonian method, which is the simplest method we've ever developed. So obviously we see that there's 4 of these 10, which is 10 times 4 is 40. And then we just simply add 1 due to this right here. There's just one of them equals 41. Simple enough. Now this one gets a little more complicated because this is the Mayan system. And in the Mayan system, they do a base of 20 rather than 10, so it's not as simple as counting on your 10 fingers. So when we look at this problem right here, we are going to start with 20 base of 0, and so on and so forth. So this will be 20 the base of 1, 20 base of 2, and then 20 in the base of 3. Okay, so let's start looking at the images. So we see right there at the first one, we have just the line which represents 5. So we're going to put right here. Sorry if this gets a little messy. It could be really hard to follow along. We have 5 times 20 to the third power, which is 8,000. 8,000 parentheses plus. Next one is right here, so it's 6. And then we have 6 times 20 to the second power, which is 400. 6 times 400 plus, we're still adding, and we go down here to the 3 dots, it's 3. And then we have 3 times, and then 20 to the first power is actually just 20 plus, and then right here, we get a little confused looking at these 2 dots and then these 2 dots, but it's actually 17, and it would be times 1, so we're just going to add 17 right there. And if we calculate that all up, it'll give us 42,477. It's not as complicated as it seems once you break it down and get to see how it actually evolves. Let's move on to something a little more difficult. So have you ever tried to work out a long multiplication problem? It's just not working. You can't find out what you're doing wrong. You're not adding something right. Okay, so this is actually called the lattice method, and we use the lattice method to solve math equations, or I would. So we start by putting 28 at the top here, and then we'll put 32 on the side here. So notice we have these little boxes. It'll come to you in just a second. So I'm going to use my calculator to make sure all my calculations are correct because I don't want to give you false information. So 8 times 3 is 24. And we're going to put that in this box here. We're going to put the 2 on top, and we're going to put the 4 on the bottom, representing those 2 multiplications. And then 2 times 3 is 6. And since there is no tens place for the 6, we just put a 0 there. And then we put 8 times 2 is 16. Put the 1 there, carry the 6 right here. 2 times 2 is 4. So again, put the 0 here and add the 4 right there. So you're probably thinking, well, how does that help anything? So we broke it down by multiplying this big number to multiplying them individually. And then we're going to start by adding vertically. So instead of starting from left to right like we do on paper, we're going to start from right to left, which may seem a little odd and awkward for you. So we have 6 here, nothing to add. So we have 8 and 9. 4 plus 4 is 8, plus 1 is 9. And then we have 6, 7, 8 right here. And then we have 0. So our total should be 896. This is how we get our answer. And voila, there it is. So let's do one a little bit more difficult than that one. We're just going to add another set of numbers. So instead of 2 numbers, we're going to have 3. So here's 2, 73. And on the side here, we're going to have 6, 28. Sorry, guys. All right, so let's start this again. 6 times 3 is 18, so we're going to put the 8 right there, carry. And we have to be very careful on how we place these, because one little wrong mess up will ruin the whole problem and you'll have to start all over. That's the bad thing about lettuce method. If you can't spot it out then and there, it's going to take a while to spot it out. So let's do 7 times 6 is 42. Put the 4 here. 2 times 6 is 12, so add the 1, put the 2 there. All right, we got 6 done. 3 times 2 is 6, so put 0, 6. And then let's just go ahead and go all the way down. 3 times 8. 3 times 8 is 24, so let's put the 2 here. 7 times 2 is 14, I believe. I just want to double check. Don't want to put any false information on here. And then 7 times 8, I do need a calculator for that. It's 56. 56. And then 2 times 2 is 4. And then 8 times 2 is 16. Let's double check that. We're on a good start. And then we will be adding these across just like we did in the other one. Sorry, that got a little messed up. So we'll leave the 4 here. And as we can see, 6 plus 6 is 12, 13, 14. We're going to carry the 1 there like we would an additional problem. Put the 4 here, and then that will make 9. So we have 9 plus 4 plus 5 plus 6, which is 24. So we're going to carry the 2, leave the 4 here yet again. Let's actually erase some of that. That way it doesn't get confusing. It's my fault. Apologize for that. All right, so now we have 2 plus 2 is 4, 5, 6, 7, 8, 9, 10, 11. Add the 1, put the 1 there, 4, 5, 6, 7, 7, and then we have 1. So our answer should be, and we will double check it in just one moment, 171,444. See if that's what we got, and that is what we got. So as long as we make sure we're doing it step by step and not over rushing or overwhelming ourselves, we'll do fine. So same problem, put 964, and then we have 593, and let's start at the top again. So 4 times 5 is 20, so we're going to put the 2 here, the 0 at the bottom. 9 times 4, 36. 4 times 3 is 12. And then we got 6 times 5 is 30. 9 times 6 is 54. 6 times 3 is 18. And then we have 9 times 5 is 45. 9 times 9 is 81. 9 times 3 is 27. Sorry, I just wanted to make sure I gave everybody the correct calculations. No difference here. We are just going to add vertically one more time. That one I got a little out of line. So again, start from right to left. So we have 2, and then we have 8 plus 1 plus 6 is 15. Leave the 5, carry the 1. And then we have 7 plus 1 plus 4 plus 3 plus 1 is 16. Leave the 6, carry the 1. And then we have 2 plus 1 plus 5 plus 2 plus 1 is 11. And I apologize, I'm using my calculator. I'm not trying to leave time for mistakes. So we have 8 plus 5 plus 3 plus 1, 17. So we're going to carry the 1, and 4 plus 1 is 5. So our answer should be this answer right here. So it should be 571,652, and that's what it is. See, it's very simple. Now we're going to add one more number to this. And it's going to seem like it's just so terrible, but really it's not. It's simple. We just take it step by step. Alrighty, and then we have So very self-explanatory. Just add the top, multiply the top row by the right-hand side, 1 by 1, and we'll be good. And then we have, make sure you can see that that's a 2. We have 2 plus 2, 2 times 2 is 4, excuse me. Did not mean to say that. 4 times 2 is 8. 2 times 3 is 6. Can't even tell it's a 6. All right, 5 times 2 is 10. 5 times 4 is 20. 5 times 3 is 15. 9 times 2 is 18. 9 times 4, 36. 36. Sorry, make sure it's clear. 9 times 3 is 27. 27. 4 times 2 is 8. 4 times 4, let's double check, 16. 4 times 3 is 12. All right, and now all we have to do is add, go all the way back down. All right, so we have 6, 8 plus 5, 13. So here's the 3, carry the 1. We have 4 plus 1 is 5, plus 7 is 12. Leave the 2, carry the 1. So we have 2 plus 2 plus 6 plus 3. No, actually, sorry, that's 2, excuse me. Plus 1 is 13.